studying sampling theory, they can refer to such books. There are other some standard books are also there, but these are some of the important books. So we are moving forward, and first we will have to know that why we need sampling. Here it has been said that the basic input in statistical analysis and inference in the data is the data. So statistical analysis, whenever we do some kind of statistical analysis, we need data, and we have to make conclusion regarding that particular analysis. But before that, the data should be collected in a proper way, with a proper method, with a proper technique. So after full stop, the data can be collected either by experimentation or by sampling methods. So there is a two way of collection of data. In lab experiment also we can collect and we can observe through the experiment that is conducted in the lab, as well as the data that will be collected in the field through sampling technique methods will be the sample that will be collected from the population. The sampling methods have been extensively used for a variety of purposes and in a great diversity of situations. For example, a consumer wanting to purchase a commodity inspects a portion of it. In industry, the quality of product is assessed through sampling, etc. There are numerous applications of sampling. If some industry, they want to verify the quality of the product, they will take a sample from that commodity and they will try to observe that the commodity is up to the standard mark of that particular industry which has been producing this commodity year by year. Okay, and in agriculture also, some of the insecticides or pesticides that has been used in the field, that could be also be their quality also could be tested through this sampling. Okay, they cannot test all the insecticide that has been developed by a particular company or pesticides. They will just take a sample of pesticides or insecticides, then they will apply to a particular crop or particular where they have their applications. Then they will observe either the pesticides or insecticides are having the up to that mark quality or not. Okay. So now we are moving forward and we'll be knowing what is population. So population, we all know, when we if someone asks us this what is population, then we directly first and foremost that is come to our mind that it is the population. They are talking about some country or some place, some state, some region. But in statistics, population has a unique definition. Population under study. Whenever we have to collect the data regarding some kind of analysis, we have to collect it only from the population that is under study. Population with a similar characteristics. If I say an example of your, if we are doing a study related to this agriculture university student, then we have to take the population under study of this agriculture university student of all the boys as well as girls. Then we will be conducting the survey with a sample drawn from that particular population. Okay, and here one term is there in this particular slide, that is complete enumeration. The information collected for each unit of the population is known as complete enumeration. Complete enumeration in the sense that census survey is a complete enumeration survey. Okay, every 10 years in our country and other country also, in a particular specific time interval, the census survey has been conducted. Numerous information has been collected by the investigator or the person who visited a particular household with a particular sets of schedule. Then he asks all the questions. So complete enumeration, Census of India is an example of complete enumeration. And similarly, sample survey. This is totally different from complete enumeration. This is a portion of the population has been only taken in the sample survey. So not whole population is considered in sample survey. Okay. It may not be possible to collect information on all units of a population due to various reasons. There are various reasons due to which we cannot collect the information regarding this sample. Population কাৰণে আমি যেতিয়া এটা population approach কৰো তেতিয়া different reason থাকিব পাৰে আমাৰ যেনেকৈ আমি population to গোটেই enumerate কৰিব নোৱাৰো তেতিয়া these are some of the reasons. Say one reason is lack of resources in terms of money and personal equipments. Another reason is that experimentation may be destructive in nature. For example, efficacy of insecticides, quality of firecrackers. So destructive population karano we have to go for sampling. If the firecracker company wants to check the quality of a particular say cracker, then he cannot light all the crackers. He have to take a sample of that particular cracker that the company has been developing, and then he will observe that either the quality of the crackers are up to that mark or not. Okay. So this is some kind of pictorial representation of a sample and a population. So sample is a, as we can see, sample is consist of large number of peoples in terms of, population is consist of large number of peoples in terms of sample. Okay. Now these are some of the points where we can discuss about the sampling and complete enumeration. Sampling and complete enumeration. Why sampling is better or why complete enumeration is better? These are some of the 5 points has been discussed in this particular portion, but there are numerous points why sampling is better or why complete enumeration is better. The first point is that complete enumeration will take longer time as compared to the sample survey. It is obvious because complete enumeration consists of all the population that has been included, and sample survey will be less costly than a complete enumeration of the population under study. So due to less population in sample, we have less time and we will be having less money, less amount of money will be invested in the sample survey. So second point says that the involvement of large number of investigators, serious biases, non-sampling errors are expected in complete enumeration. In sample surveys, such risks are comparatively less. However, if the information is required for each and every unit of the population, a complete enumeration becomes necessary. So if some informations are there regarding this complete enumeration, so we have to move towards complete enumeration, not for some sample survey. Okay. So complete enumeration here, example also has been given. It is population census of India. So this is an example of complete enumeration that has been conducted every 10 years in our country. And this particular census, this coming census draft will be, I think it will be presented in 2023, in coming year, February or March. It will be giving us information that how much literacy rate has been increased or how much poverty has been decreased. Like this, numerous information could be gathered from this census survey. Okay, so it's an important. And according to that census that has been conducted, according to that, the ministry will make some plans regarding health plans for common individual. Okay, so these are important things. So this third point says that sample survey has generally is greater scope as compared with complete enumeration. So it has a somewhat greater scope. Scope has a particular meaning. For this also it has a specific meaning. Scope বুলি কলে আমি সাধাৰণতে যেতিয়া আমাক যদি কোনবাই হুদে যে এই সাবজেক্টটো পঢ়িলে স্কোপ কি আছে তেনেকুৱা ধৰণৰ স্কোপৰ কথা কোৱা হোৱা নাই। It is a broad term for this particular point of view, sampling as well as complete enumeration. We have to see it as a broad perspective of ami sabo laibo je scope ki ase amar sampling ot. If testing is destructive, the fourth point says that if testing is destructive, that is if the quality of an article can be determined only by destroying the article in the process of testing, complete enumeration is impracticable and sampling technique is the only method to be used in such cases. So juntu my earlier slides kekhonot mention korisilu je jodi amar population to destructive hoy, it's some kind of matchbox producing company or some kind of firecracker producing company. Similarly, when the population is destructive, we'll have to go for sampling, not for your complete enumeration, because complete enumeration will ki koibo totally population to mane tumar hack hoi joa nisna hobo aru tumar. And the fifth point says that if the population is hypothetical, as for example in coin tossing problem where the process may be continue indefinitely, sampling method is the only method is used in such situations. So hypothetical population karno ami sampling approach sampling technique approach koribo paro. Hypothetical in the sense that if I take an example of one boy and one girl from this particular class, if she is tossing a coin 100 times and the boy is tossing a coin 200 times, so both for boys and girls the population will be different. So it's a hypothetical population. How many times a person toss a coin, throw a die, it will depend upon the person. Either his population is 200, 500, 600, like this way. So for this case, population is not constant. It's a hypothetical population. So for in that type of cases also, we have to approach the sampling. And here, while studying sampling theory, we came across two types of error: sampling error and non-sampling error. Okay. So sampling error is a type of error occurs due to the sample selected does not perfectly represent the population of interest. the error could be possibly reduced with the increase in the sample size. So in this particular sampling, while collecting the data, we came across two types of error. There is sampling error and non-sampling error. And sampling error is due to the sample that has been collected from the population. It is not if it is not a proper representation of the population, then it is not a valid sample. And it cannot be inevitable. It cannot be controlled. Sampling error cannot be controlled in sampling theory, but it can be reduced. Reduced in the sense that if we increasing the sample size, then the difference between the population and the sample will be becoming less, and it will be a proper representative of that population. And if there is some kind of bias, human error is there. If we conduct a survey regarding household survey in Jorhat district, in some kind of urban area, then the person residing in that particular ward or particular household, he will be only collecting if the data from that particular neighborhood household and omitting other household, then it will be a biasness. The sample will be collected in terms of human error, and different types of techniques. If he is not trained enough to conduct this particular survey, then there also the human error could arise. Okay, so these are all the examples of non-sampling error, and non-sampling error cannot be reduced or increased. Okay, if we increase the sample size, so it has nothing to do with sample size. If we are taking a small sample as well as a large sample, it is due to the human error. So there is some kind of non-sampling error always. So according to you, census has a non-sampling error or sampling error? Census has a non-sampling error. There is no such for sampling error, because census is a complete enumeration of the population. So sampling error cannot be arise in census. Okay, this is an important point while studying this non-sampling error and sampling error, because complete enumeration of the population has been done in census. So sampling error is not there in census, but sample survey has both sampling error as well as non-sampling error. And sample survey are done in our country by some of the organizations of Ministry of Statistics and Program Implementation is there in our central. National Sample Survey Organization, NSSO, they do some kind of surveys like socio-economic surveys there, your labor force surveys there, and different types of surveys are from day to day period of time they conduct, okay, in our country. But they don't study the whole population. They take a portion of the population and they give a certain kind of inference, certain kind of conclusion regarding the population. So these are two types of error we have came across, and these are some of the concepts we have to understand while studying this particular sampling. The first is unit, a distinct and identifiable element from which required information can be ascertained or on which observation can be made is known as a unit of the population. If I say we are conducting a survey regarding this household, then a single household will be considered as a unit. If it is a field of paddy plants, we are doing some kind of agriculture survey, then one paddy plant will be considered as a one unit. Okay. If this is a population of your the study has been done in your university, then your students will be considered as a unit. Okay. And what is population? Population is the aggregate of all the units. Means your whole students will be considered as a population under study if we are doing this particular survey in your university. Okay. So aggregate of all unit is known as population. Population may be finite or infinite. Infinite population example we all know. We can consider the stars in the sky. This is an infinite population. We cannot we cannot count. We can count, but it is numerous, infinite. Then there is discrete or continuous, existent or hypothetical. Different types of populations are there. So some examples has been given in this particular slide. That is all paddy plants in a field, all households in a locality, all farms in a village. These are etc. etc. These are some of the examples of population. Okay. So here two terms are there. One is frame and one is sample. Frame in the sense that if we are doing this particular survey while drawing a population from the while drawing a sample from the population, then we required a sampling frame, means a list of units or list of people from which we can understand that this is our population, and from this population we have to draw a sample. Say in simple, if we have a list of voter people in India, and we are doing some survey regarding this or peoples, then we can have that particular list of 500 or 1000 student 100 people, 1000 people, and it will be considered as a sampling frame for us. Okay. Then what is sample? Sample is a portion of the population. It is not the whole population, but a portion of the population. And for statistical inference about population from a sample, it is essential that samples are representative of the population. So it is an important point in sampling theory that samples should be a representative of the population. If it is not a representative of the population, then we cannot make some kind of inference or conclusion regarding this population. Okay. Now we are moving towards the definition of sampling, and we will be observing here two types of sampling: probability sampling as well as non-probability sampling. Probability word we have all came across: probability of an occurrence of an event, probability of non-occurrence of an event, like this way. So the definition says that the process of selecting a sample is known as sampling. So there will be a specific process how we can select a sample from that particular population. So for different situations, different sampling methods were evolved. They are classified into two types. So broadly, sampling methods are classified into two types, that is probability sampling methods and non-probability sampling methods. So we are moving forward now. So this is a pictorial representation of what are the sampling methods in both probability as well as non-probability sampling methods. Probability sampling method, we have simple random sampling, cluster sampling, systematic sampling, stratified random sampling. Similarly, in non-probability sampling method, we have convenience sampling, judgmental or purposive sampling, then snowball sampling, quota sampling. Okay. So probability sampling methods has a there has an application of probability in the sampling methods, but non-probability sampling methods, as we can see from the names also, judgmental sampling method or purposive. Judgmental and purposive words has a specific meaning. It is about the person who is collecting the sample from the population. It is according to his judgment or his purposelessness that he can collect a sample from a population. Then your convenience word also has a specific meaning here. According to his convenient approach, he can collect a sample from that population. Then snowball sampling, we have all came across snowball sampling. Snowball sampling is done basically the population for which we hard to reach population, we can go for snowball sampling. Okay. So the different types of population and different types of sampling methods are there. We can approach each population with different, according to the population, we have to approach the sampling methods. So these are some of the, I have already mentioned only, types of probability sampling methods. There is simple random sampling, stratified sampling, systematic sampling, cluster sampling, then your multi-stage sampling. So we have, and other some kinds of sampling methods are also there, probability sampling methods. So these are some of the types of non-probability sampling methods. Already we have discussed only judgment sampling, purposive sampling, quota sampling is there, then your snowball or network sampling, volunteer sampling, etc. Okay. So in this particular slide, whenever we have to draw a sample from a population, it will be either sampling with replacement or sampling without replacement. Replacement word means in the sense that if we drawing one unit from that particular population, then we are break that particular unit in the population, then it will be a sampling with replacement, because we have replaced the unit that has been drawn again to the population. But sampling without replacement means the unit that has been drawn from that particular population is not replaced again. It has put aside, then again other unit has been drawn. Okay. So this way the sample, the population will be becoming less. But in case of sampling with replacement, the population will never become what? It will never reduced. It will be of same size, same population. When the successive draws are made with placing back the units selected in the preceding draws, it is known as sampling with replacement. When such replacement is not made, it is known as sampling without replacement. So in your syllabus, there is only one probability sampling method that will be discussed. That is simple random sampling method, and it is one of the most simplest of all probability sampling methods. And it is used in the case when the population is homogeneous. And the homogeneous in the sense that all the population, the population under study should have a particular similar characteristics. Okay. If I take the population of this particular university of a particular year of student, that it will be our homogeneous population, because all are studying in a same particular year, but they, no doubt they are difference of gender, but the population will be homogeneous. But if I add some kind of old people here in your this particular population, then it will be a heterogeneous population, because old people or some kind of middle-aged people and your age will be different. So this way, the population which are homogeneous with a particular sum of the characteristics, that will be considered for this particular simple random sampling method. Okay. When the units of samples are drawn independently with equal probabilities. So each unit has a equal probability of drawing from that particular population. Means if there is a 10 number of units in the population, then our probability will be, for each unit will be 1 by 10, 1 by 10, 1 by 10, 1 by 10. Each have equal probability of drawing of sample from that population. And in short, we can say it is a SRS, sampling, simple random sampling. The sampling method is known as simple random sampling. So this slide also said that only the sampling units are chosen without replacement, because the units once are chosen are not placed back in the population, and the sampling units are chosen with replacement because the selected units are placed back in the population. So in two possible ways, we can draw a sample from that population by the use of this simple random sampling method. So simple random sampling, first we will observe for with replacement. Simple random sampling with replacement, SRSWR, is a method of selection of small n units out of the capital N units one by one, such that at each stage of selection, each unit has an equal chance of being selected, and units are replaced after each selection of units. So in statistics, we denote the small letter as sample. For small letter in statistics has been denoted as sample, and for capital letter, as we can see in the slide, capital letter will be denoting the population. Okay. And what is the probability? Here probability also has been mentioned. It will be 1 by n to the power capital N to the power small n. That is the probability of each unit of the population that will be drawn through this simple random sampling with replacement. And how many possible sample we can take, we can get, that is n to the power small n. If we consider a population size of 10 and we are drawing a sample of 2, then how many units will be there? Total possible samples 10 to the power 2. That will be how much? With replacement. But it will be that figure 10 to the power 2, 10 square. Okay. So it will depend upon the population size as well as sample size, how much we are drawing from that particular population. So this is some kind of pictorial representation what is happening in here in simple random sampling with replacement. An object has been drawn from that particular jar, then it has again been replaced. Okay. It has been recorded. First it has been drawn from the jar, then it has been recorded, then again it has been replaced. Okay. So this way in simple random sampling with replacement, we will be drawing the particular unit from that particular population, and again it will be replaced back to that particular population. Okay. And here we can observe simple random sampling without replacement, SRSWOR. Simple random sampling without replacement is a method of selection of small n units out of capital N units one by one, such that at any stage of selection, any one of the remaining units have the same chance of being selected. So here the units are not replaced back. In simple random sampling with replacement, the units have been replaced back. We have recorded the units, then again it has been replaced back to the population. But simple random sampling without replacement, here the unit will be recorded, but it will not be placed back, but it will be kept aside. If small n units are selected by simple random sampling without replacement, the total number of possible samples are NCN. NCN means C stands for combination. We have got this particular term in our high secondary, I guess, permutation and combination. So if we have 10 sample and we are drawing a if we have 10 population units and we are drawing a sample of 2, then our possible sample will be 10C2, and the formula for this particular combination formula is nothing but what? N factorial divided by small n factorial, capital N minus small n factorial. NCR we have got for NCR, but that same formula will be applied here. Just your terms has been replaced by, in terms of R we have written small n. And the probability of selecting any one of the sample is nothing but 1 by NCN. Okay. This is an important slide. Those who have not written this particular slide, right? Yes, yes, sit down. Sit down in first bench. Everybody write this particular slide. This is an important slide regarding simple random sampling without replacement. And this earlier slide was also important. It was for simple random sampling with replacement. So we are moving forward now. Okay, now we will be looking at the next slide. So this is some kind of pictorial representation of simple random sampling without replacement. This particular persons that has been drawn from this particular sample, population, will not be replaced back again. That was in the case of simple random sampling with replacement, that the object will be drawn from that particular jar and that has been recorded and that has been again replaced back to the jar. But this person, this sets of person that has been drawn as a sample from this particular population will not be replaced back. And this is the core difference between simple random sampling with replacement and without replacement. So how we can draw a simple random sample from a population? By using these two methods. One is lottery system method and one is mechanical randomization or random numbers method. So some persons, some statistician has developed some kinds of random number table. Tippett's random number table is there. Fisher and Yates random number table is there, and numerous some other two tables were there. And we all know Fisher. Who is Fisher? Ronald A. Fisher is our father of modern statistics. So he, with some person Yates, they had also developed one random number table. But mostly researcher as well as in institutes, the Tippett's random number table is available. The random number table is also available in internet also. We can observe the PDF form by downloading it, and just look how the random numbers are placed in that particular table. And lottery system method, we all know what is lottery system method. Equal size and equal, if there is a capital N units of population, the seats will be prepared of equal size as similar as possible. Then some person will shuffle it, and some person will draw some kind of sample from that particular N capital units population. Okay, this is some kind of lottery system method. But lottery system methods is not applicable for large number of population, because for large number of population, say 1,000, 10,000, 20,000, we cannot go for lottery system method. Okay, that's why the simple random sample, to draw a simple random sample from a random number table, the mechanical randomization or random number method is there. Okay. So in this particular site, how the random number table look, that has been discussed. A random number table is a series of digits 0 to 9. So it will be consist of 0 to 9 digits. We all know what digits are there in 0 to 9. Arranged randomly in rows and columns as demonstrated in the small sample shown below. Means in the next slide, a small portion of the random number table in the very next slide is shown there. The table usually contains 5-digit number. So randomly 0 to 9 digits are there in our random number table, but the 5-digit numbers are there in the table. Arranged in rows and columns for ease of reading. Typically a full table may extend over as many as 4 or more pages. The random number tables are in most statistical textbooks. Yes, we can observe the random number tables in some kind of statistical textbook also. There is Gupta and Kapoor, this fundamentals of mathematical statistics. In backside of we can observe in the appendix portion also there is I think there is the random number table should be there, I guess. So there are some kind of Tippett's random number table is there, that has been developed in 1927. Then Fisher and Yates, it was been developed in 1938. And Candle and Babington Smith, they had also developed a random number table in 1939. So there are other random number table was also there. So this is a form of random number table that I was talking about. So it's a 5-digit number that has been written in column as well as in row, and the numbers from 0 to 9 digits are arranged randomly. So with the help of this random number table, we can draw a sample from that particular population that has been studied or that has been observed. Okay, with the help of this. So if we take this particular example, 2 examples, drawing a random sample without replacement of size 15 from a population of size 500, and if we have to draw a random sample of size 10 from a population of 1000. Okay, these are 2 of the practice problems we can consider while drawing a sample from this particular population with the help of this random number table. But there are some kind of steps are there that we must have to follow while drawing a simple random sample from this particular population. So these are some of the steps. They are there. First step is first we have to identify the population of capital N units. That is 1 to n, capital N. We have to identify it. Then our second point says that select a random page from the random number table. So there are numerous pages of the random number table, and we can select a random page. We have to select it randomly. Then third point says that select randomly any number on that page by moving row wise, column wise, or diagonally. Okay. From this random number table, first we have to select a random number page. Then we have to select a row wise or column wise or diagonal wise column from that particular random number table. Then our fourth and important point says that depending upon the population size, that is n equals to 500, 1000, 2000, like this way, we select one by one random number from the table until complete sample is selected. Okay. So depending upon the unit of the digits there in the population, we can go for selecting the sample from the population. If the and the last line here says that the numbers above capital N are discarded. That means if the population is 500, then above the if we are getting random numbers 501, 502, 503, that will be what? That will be discarded. That will be omitted, because we don't have the sampling frame of that 501, 502, 503. We have only a sampling frame of 500. From that 500 population, we have to draw a sample of either 15, 20, 30, like this way. Okay, but we cannot go beyond the population size. So write these points, those who have not written. These are important points, these 4 points. How to select a random sample from the random number table. Those who have not written, write this particular slide. These are 4 of the important points we have to know while selecting a random sample from the random number table. So there is only one simple random sampling method we have discussed today, because in your AG Stat 212 course number paper statistical methods, here only one probability sampling methods technique was there in your syllabus, but there are other sampling methods also there, and they have each have its own method of how to draw a sample from a population. Okay, so this is the first and foremost probability sampling method, simple random sampling method, and it is the most simplest. Just we have to know how to draw a random sample from the random number table, and we can proceed both row wise also. We can select the random numbers, column wise also we can select the random numbers, as well as we can go diagonally also. Nazman Sitano. লিখিলা যদি রিপিট নিলিখিবা যোনখিনি যদি অলৰেডি যোনবোৰ লিখিছা কিন্তু কিছুমান স্লাইড তোমাৰ স্কিপ কৰা হৈছিল ন এইখিনি Okay, now we'll be looking Now just we'll be looking how to draw this particular random sample of this. We will be taking only example, this first example. Just will you observing the table? This is the random number table. A sample of 15 has to be drawn from a population of 500. Now our population unit is how much? 3 digit? 3 digit, and we have to consider this is a 5-digit random number table, but we have to consider 3 digits from these 5-digit random numbers that has been arranged 0 to 9 digits randomly. So if I consider the first column, first 36518, so 365 could be included in our sample. Similarly, if we go row wise, column wise, but this all has to be done in a random fashion manner. That is the whole purpose of this particular method, that it should be random. We have to randomly select the page from the random number table. We have to randomly select the row, column, or diagonally randomly we have to select. So all this, when we have to draw, we cannot purposefully select any column or any row according to us, but in a random way we have to select the column or row. From that column or row we are drawing that particular sample of either 15, 20, 10 sample from that particular population unit. Either it is 500, 1000 or any finite number of population. So with this particular slide, I am concluding this particular lecture today, sampling theory. This is an important aspects of statistics, and all the research persons as well as in agriculture field, as well as it's a concept that has been used by non-statistics person also. Okay, so they try to gather the appropriate sample from a population. I hope everybody has understood this particular lecture. Okay.